Alright, good day everyone. So welcome back to my YouTube channel. And today we'll be talking about application of the normal distribution. So application of normal distribution. To solve problems by using the standard normal distribution, transform the original variable to a standard normal distribution variable by using the formula z is equal to value minus the mean over the standard deviation. So this is the formula that we're going to use. Z is equal to the value minus the mean over the standard deviation. So procedure, so finding the area under any normal curve. First, step 1, draw a table, normal curve, draw a normal curve and shade the desired area. Step 2, convert the values of x to z values using the formula x minus the mu over the standard deviation, and find the corresponding area. So these are the steps that we need to follow for application of normal distribution or finding the area under any normal curve. Okay, so let us have example number 1. An adult has an average 5.2 liters of blood. Assume that the variable is normally distributed and has standard deviation of 0.3. Find the percentage of people who have less than 5.4 liters of blood in their system. So the first step we have to is we need to draw or create a standard normal distribution curve to represent this one. So if the average is or the mean is 5.2, and what we're going to find is the percentage of people who have less than 5.4. So therefore, if this is 5.2, let us assume here this is 5.4. So if that is less than here, so this is the shaded part of our normal curve. So a standard deviation of 0.3. Find the percentage of people who have less than 5.4 liters of blood in their system. So second step is we need to convert this x into a z value. So what is our x here is this one, 5.4. So we have to convert this one into a z value. So 5.4, so therefore z is equal to x minus the mu over the standard deviation. So here, what is our x is 5.4 and our mu is equal to 5.2 and our SD is equal to 0.3. So 5.4 minus 5.2 over the standard deviation of 3, 0.3. If we're going to divide that one, this is 0.2 over 0.3, that is equal to 0.67. So this is now the value for our z, which is 0.67. Okay, so we have to look for the value for our z here in the table. So try to look at 0.67. 0 to 67 here. 0.67 in the table. Okay, this one. The value for the area is 0.7486. So 0.7486 is the value. So we have here. So when that is the left of the z value, meaning to say we're going to make use of the area provided in the table. So therefore, this z area of 0.67 is equal to 0.7486. So this is now the area. So therefore, if we're going to illustrate that one by step number 3, we could have this one, we could re-illustrate using the z value here, if that is the mean 0, and the resulting z is 0.67. So that is below the, below or less than 5.4 liters, that is converted into 0.67. So this is now a conversion or being transformed into a z value, which is 0.67. So we can say that the percentage, or therefore we could have that 74.86% of adults have less than 5.4 liters of blood in their system. Okay, so this is a conclusion. We have step 1, step 2, and step 3. So the adult, or 74.86% of adults have less than 5.4 liters of blood in their system. So this is problem number 1. Okay, let's proceed with problem number 2. Each month, an American household generates an average of 28 pounds of newspaper for garbage or recycling. Assume that the variable is approximately normally distributed and the standard deviation is 2 pounds. If the household is selected at random, find the probability of its generating between 27 and 31 pounds per month. So there are two problems that we need to solve. First, let us have problem letter A. Okay, so in this case, we have to draw a normal distribution curve here. And this is the average of 28 and between 27 and we have here 31. So this is between 27 and 31 and the average is 28. We need to transform these two values, which are 27 and 31, and get the difference of the areas in order for us to get the z value for 27 and 31, or the area of the two, in order to get the probability between 31 and 27. So we have to transform this one. For letter B, step letter B, step number 2, and this is step number 1. And step number 2, we have to transform x is equal to 27. So z is equal to, where x, our mu is equal to 28, and our SD is equal to 2 pounds. So x minus the 27 minus 28 over 2, which is our standard deviation. This is negative 1 over 2, or this is negative 0.5. So this is a z value. And we have here the next one, z is equal to 20, 31. So our x is 31. So we need to convert this one. X is 31. So 31 minus 28 over 2, that is equal to 3 halves and equal to 1.5. So next step, we need to find the values of this one. So the value for this one and the value for this one, and we need to subtract in order for us to get the probability. So what is the area of this one? So first is negative 0.5. So let us locate negative 0.5 here. Okay, negative 0.5 is this one. Okay, this one. 0.5, this one. So 0.30585. So this is 0.3085. And for 1.5, 1.5 here, and this one, we have 0.9332. Okay, so 0.9332, so 0.9332. So we have to, step number 3, we have to subtract the area of the bigger one. So the area of z 1.5 minus the area of z negative 0.5. So this is 0.9332 minus 0.3085. So the area is equal to, if we're going to subtract, that is 0.6247. So therefore, if we're going to re-illustrate this one by the use of this one, this is the mean, and this is 1.5, and this one is negative 0.5. So this one, the area of this one is 62.47%. So 67.47%. So that is the probability. So therefore, the probability that a randomly selected household generates between 27 and 31 pounds of newspaper per month is 62.47%. So that's how to solve for letter A. So let's proceed with letter B. In solving with letter B, same process did what we did with problem number 1. Since first step, letter B, so the first step is we need to have the normal distribution, which is 28 and more than 30.2 pounds. So therefore, this is more than 30.2 pounds. So that is, we need to convert first. In step number 2, we have to convert x is equal to 30.2 and our mu is equal to 28 and the standard deviation is equal to 2. We have to convert this one. So z is equal to 30.2 minus 28 over 2. So that is equal to 2.2 over 2, that is equal to 1.1. So we need to find for the z 1.1 the area for this one. So z 1.1 area. So if we're going to locate that one in a table here, okay, 1.1 1.1, so this is 1.1, the area is 8.8648. So this one, 8648. So we have the area of 0.8640 43. Okay, 43. 86.43. 0.86.43. Since that is more than or that is left of right of the z, so understood we need to find uh, the case number 2, which is 1 minus 0.8643. So we have to subtract it from 1, so 86.43. So the result of this one is equal to 0.1357. So step number 3 is we need to convert this. Okay? The mean is equal to 0 and the result is 1.1. So that is above 1.1. So this is 13.57%. So above 1.1, as our z value is 1.1, that is 13.57%. So therefore, we could say that the probability of randomly selected household will be accumulated or generated more than accumulated more than 30.2 pounds of the newspaper. Okay, so that is 13.57%. So that is how step 1, step 2, and step 3. Therefore, the probability of randomly selected household will be accumulated more than 30.2 pounds of the newspaper is 13.57%. Okay, so let us have problem number 3. So a desktop PC uses 120 watts of electric per house based on 4 hours of use per day. Assume that the variable is approximately normally distributed and the standard deviation is 6. If 500 pieces are selected approximately, how many will use the less than 106 watts? Okay, so first is we need to draw step 1. So we have to draw a standard normal distribution curve here. Okay, this is the desktop. Okay, so we have here the average per house use per day. So 120 and approximately will use less than 106. So less than 106 here. Let us assume this 106. So this is less than 106. The second step is you need to convert this x value, which is 106, and the mu of 120 and the standard deviation of 6. Okay, so convert this z, so which is 106 minus 120 over 6. The result of this one is negative 2.33. So negative 2.33, if we're going to find the area of this one, okay, z area of negative 2.33 is equal to, okay, negative 2.33, 33 here. So negative 2.33 is 0.009. Okay, this one and this one. Okay, 0.009. 0.0099. Since this is to the left of the z, so understood that this one is now the area given. Do not subtract it from 1 because the area given is 0.009. So the question is, how if 500 pieces are selected approximately, how many will use less than 106 watts of R? Since the probability or the percentage is 0.009, so we have to multiply it by 500 times 0.0099. So this is 4.95. Since this is a number of pieces, so we will equate this one into 5 PC on desktop PC. So therefore, we could say that if we're going to illustrate it back using the z value, this is 0 and this is negative 2.33 less than of this one. So we could say that uh, approximately 5 pieces 5 pieces will use less than 106 watts of power. Okay, so that's problem number 3. So let's proceed with problem number 4. In problem number 4, this is different from the in finding the z. This is different from the problem 1, 2, 3 because in this problem number 4, this is given of a percentage or the area is given. So first, the question is to qualify for a police academy, candidates must score in the top 10% on a general abilities test. Assume that the test scores are normally distributed and the test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. So the first thing that we're going to do is we need to draw. Okay. So the first move is we need to draw here. So stated here that this is the average or the mean is 200 and 10%. Okay, this is 10% or 0.10. The 10%, so this is more than 10%. How to find the value for our z here? So to find for the value for our z, in order for us to get for the value for x, so first we need to have the formula. Since what we're looking here is the possible score, so therefore what we're going to solve for this part is we need to solve for the value or data value or the possible score or the lowest score to qualify for the academy, police academy. So the formula is equal to z, x minus the mean over the standard deviation. So we have here, by using the algebra, so we need to equate this one. So z standard deviation is equal to x minus the mu. So to solve for x is equal to z times standard deviation plus the mu. So this is now how to find for the value for our x. Since we need to find, we have now the value for our mu here, which is 200, and the standard deviation, we need to find for the value for our z in order for us to solve for the lowest possible score to qualify. Okay, so what is the value now? So in order for us to get the value for our z, we need to use the 10%. Since that is more than, so therefore, we have to use the case number 2, which is 1 minus the area in order for us to get the value for our z here. What is the z value when it is 10%? So the area 1 minus 0.10 is equal to, we have here the result of this one is 0.900. So we have to locate for this area in order for us to get the z value. So 0. This is on positive, more than 0.5. So that is more than 0.5. Okay, so I have to locate for 90.90%. For 90%, here 90.90%. Okay, so the nearest one is this 0.8997 because it's 0.905 and this is, so the nearest one is 1 point. Alright, this one is 1.28. Okay, so our z here is equal to 1.28. So the nearest value for that one is 1.28. So we have here 1.28. So if the case is this, Okay, 1.28. If the case when the values are, for example, this one, if the case is the values between higher or lower, we need to use the higher z for this case. Okay, so we have here, okay, so now we have now the value for our z, 1.28. So we can now simply substitute here. So our x is 1.28 times the standard deviation, which is 20, plus the mu of 200, and this is standard deviation, which is 200. So x is equal to 1.28, okay, 1.28, this is 25.6 plus 200. So x is equal to 225.6. So since we need to get the possible score, we need to get the cutoff score. So approximately 226 would be the cutoff score. So when this one x is greater than 226, will pass or qualify for police academy. Qualifies for police academy. So we have here the score 226 would be the cutoff basis in order for someone to qualify for a police academy. Okay, that's 10%. Okay, proceeding to question or problem number 5. For medical study, a researcher wishes to select people in the middle 60% of the population based on blood pressure, assuming that blood pressure readings are normally distributed and the mean systolic blood pressure is 120 and the standard deviation is 8. Find the upper and lower readings that would qualify people to participate in the study. What we're going to do is first we need to illustrate the problem. Here, if the mean is 120 and that is the middle of 60%, so if this is the middle of 60%, if this is 60%, so therefore this part is 30% and this one is 60% here. This part and this one is 30%. And this part would become 20%. This is the middle and this is 20%. So first thing is we need to convert or we need to find for the values here. What is the value for RZ? Since this is of what is the value for RZ here? Since this is 30% and 30% or 60% in the middle. So what is the value for RZ here would be the value for this one. The symmetrical. First, if this is 30%, we could have this one is 0.5 plus 0.3. So this part. Because this part, if we're going to make use of the case number 1, this part is 0.5 and this one is 0.3. So therefore, this is 0.800. Okay. So if we're going to look at for the table, what is the value for 0.0880? Okay. 0.880. So the closest one is this one. 0.7795. So therefore, our z value is 0.84. Okay, the closest value, so therefore we could have the z is equal to 0.84. If this is 0.84 and this is negative 0.84, since we need to get the upper and the lower readings to qualify to participate in the study. Okay, so we have here the formula x for this one are when a z value is 0.84, x sub 1 is equal to z times standard deviation plus the mu. So we have here 0.84 times the standard deviation of 8 plus the mu, which is 120. So the result of this one is 126.72. Okay, 1.26.72, and when z is equal to negative 0.84, because it's symmetric, because it's in the middle, so we have here x sub 2, we have here z times the standard deviation plus the mu is equal to negative 0.84 times 8 plus 120. So the result of this one is 113.28. So now if we're going to draw this back here, so the value for this one is 126.72, and the lower one is 113.28. So therefore we could say that the middle 60% will have blood pressure of x is greater than 113.28 but lesser than 126.72. So these are the values of the upper and the lower readings that would qualify to participate in the study. Okay, so thank you so much. This is all about problem number 5. So try this at home. You have to solve this 1, 2, 3 problems. So I hope you learned something out of the discussion. I hope you have to solve for these 3 problems. Enjoy and have fun.